So picture this. You've got an autonomous AI agent, right? Let's say it's sitting inside your company's Slack workspace.
Right, like an automated coworker.
Exactly. And it's just chugging along, pulling financial reports, answering client questions, basically executing all these operational tasks completely on its own.
Mm-hmm.
But now, imagine it is doing all of this based on a completely outdated, hidden cache of company data. Data that literally no human being even knows exists.
I mean, it's a terrifying scenario, but, for a lot of organizations right now, it isn't hypothetical at all. It's really just their Tuesday.
Yeah, and that is exactly what we're getting into today. Welcome to the Deep Dive. Today we're exploring a massive operational crisis that is just quietly unfolding inside modern enterprises.
Because usually when people talk about artificial intelligence, the entire conversation centers around, which model is the smartest.
Right. Everyone wants to know who won the latest benchmark test. But the reality, the actual fire that's keeping data engineers awake at night right now, it really has nothing to do with intelligence.
No, not at all.
It is entirely about billing, data plumbing, and an invisible infrastructure.
Yeah.
So our source today is this really excellent piece of analysis from datapro.news. It was published on May 27th, 2026 by Samuel Williams. And it's titled Eastern Models, Western Bills, One Operational AI Tangle.
It's a great piece.
It really is.
Yeah.
And our mission today is to be your shortcut to the core of this issue.
Mm-hmm.
We want to break down how plummeting AI costs are accidentally creating these unmanageable data messes inside your company and, more importantly, how to stop it before things break permanently.
Yeah, because it really is this fascinating structural shift. What you have is a situation where the fundamental economics of the technology are changing way, way faster than the corporate infrastructure meant to handle it.
Oh, for sure.
So you get this massive collision between two entirely opposing philosophies of how AI should actually be built, sold, and, integrated.
Okay, let's unpack this. Let's break down that collision.
Yeah.
Because on one side, you have the traditional Western billing structure.
Right.
Up until recently, the market was heavily dominated by these massive frontier labs and hyperscalers. Basically, the giant cloud providers who rent out vast amounts of computing power.
And their trajectory was all about lockdown, controlled access. They were heavily migrating away from an open release culture.
Which means the business model was designed to build walls.
Exactly. If you wanted to play, you had to pay the toll.
Right.
That meant we started seeing seat licenses layered on top of per-usage billing, shrinking free tiers, and forced massive spending commitments just to get your developers in the door.
Yeah, so for companies relying on AI, the sticker shock wasn't a glitch in the system. That token price shock was literally just the Western business model asserting itself and demanding its margins.
But that incredibly expensive lockdown approach, it created a massive market vacuum.
Yep.
And that vacuum was filled by an entirely different ecosystem, largely led by Chinese firms and an Eastern operational trajectory. Because in early 2025, DeepSeek launched.
Right.
And the capability it offered at its price point was so disruptive that the article notes it landed like an accounting error.
I love that framing.
Yeah.
It landed like an accounting error.
Right, because it wasn't necessarily that it was the single most intelligent model ever conceived by humanity. It was just that the math suddenly didn't make sense anymore.
Yeah.
Companies looked at this highly capable, incredibly cheap alternative and immediately started asking, wait, what exactly are we paying our Western vendors these massive premiums for?
And the fundamental difference here isn't just the price tag, right? It's the whole deployment philosophy. Because this Eastern ecosystem is heavily focused on what we call open weights.
Yes.
For anyone not deep in the weeds of machine learning, open weights basically means the actual brain code of the model, the underlying mathematical weights that make it work, are available for developers to just download, tweak, and run themselves.
Rather than being hidden behind some corporate API that you have to rent access to.
Exactly.
And that completely changes the physics of adoption in the enterprise. Once those weights are out in the wild, they propagate instantly. Developers start making fine-tuned derivatives. Third-party vendors start hosting them for literal pennies.
Wow.
Suddenly, a small team within your company can grab a highly capable model and experiment with it locally without ever having to go to procurement to beg for a massive software budget. The barrier to entry drops to zero.
So think about it like this. The Western model was essentially like being locked into a high-end, fixed-menu restaurant. There are bouncers at the door, the menu is strictly controlled, and the bill at the end of the night is absolutely staggering.
Right.
But then the Eastern model comes along, and sets up this incredibly cheap, kind of chaotic buffet right across the street where everyone is just grabbing plates and cooking their own food in the back room.
I mean, that's exactly it. And what's fascinating here is that when the capability becomes that cheap, consumer behavior shifts entirely. Companies stop agonizing over which single perfect model to commit to.
Because why would you, right?
Right. They just start using several of them simultaneously. They'll use a heavy, expensive reasoning model for the really hard logical tasks. Then they'll route the thousands of easy, repetitive tasks to a cheap workhorse model.
Makes sense.
Maybe they even run a local open weights model on their own servers because the legal department refuses to let certain sensitive data leave the building.
So without even realizing it, they accidentally build a highly complex distributed system.
Exactly. And a distributed system that they have absolutely no blueprint for, which leads to the immediate dangerous consequence of all this cheap inference.
Right, because if everyone is just endlessly grabbing plates from this cheap buffet, the central organization completely loses visibility. The marginal cost of asking an AI model to do something has dropped to near zero.
And when the cost drops that fast, usage completely explodes. Employees are putting everything through these models.
But an organization's discipline to track where all those data calls are going, that does not evolve nearly as fast. You end up with what the article calls a shadow data estate.
Which is a huge problem.
Yeah, I think the best way to visualize a shadow data estate is to look at corporate finance.
Okay.
Imagine running a massive company where employees suddenly stop using the official audited corporate bank accounts, and instead they just start expensing everything through thousands of unmonitored petty cash drawers scattered across different departments.
Wow. Yeah.
The money, or in this case the data, is still flowing, but the finance department has absolutely no idea where it is until the whole system goes broke.
That is the perfect analogy, because instead of petty cash drawers, your company's intellectual property, the prompts, the tool calls, the responses, is now living inside the dashboards of random third-party vendors instead of your own internal tracking systems.
Right.
But here is the mechanism that really accelerates this crisis. The biggest driver of this shadow data estate isn't rogue employees trying to hide things, it's caching.
Okay, wait. I really have to push back here.
Sure.
Because when I hear the word caching, I just think of a standard technical optimization. Like, if I ask a model the same question 10 times, the system remembers the answers, so it doesn't have to compute it from scratch. Providers offer massive discounts, sometimes up to 90% if you reuse cached prompts.
Oh, yeah, the discounts are huge.
Right. So I would assume any CFO would throw a literal parade for that kind of discount. How does a simple cost-saving measure turn into a massive security breach?
Well, the CFO is definitely throwing a parade right up until the system weaponizes out-of-date information at scale.
Oh, wow.
Caching sounds completely harmless until you realize that in the AI era, a cache behaves like a full-blown, unmanaged data system, and it carries 3 massive failure modes. The first one is staleness.
Okay, walk me through what staleness actually looks like in practice.
Let's say your company updates a critical internal policy, maybe a compliance rule for how to handle a specific type of financial transaction.
Okay.
You update the main document in your internal database, but the AI provider has already cached the old document to save you money on compute costs. And your company's retrieval system doesn't force the cache to clear. So when an employee asks the AI chatbot how to handle a transaction, the incredibly fast, cheap model reaches into the cache and confidently gives them yesterday's policy as today's absolute truth.
Yes.
And because these calls are so cheap, you're relying on them constantly.
You are essentially automating misinformation at the speed of light.
Yes. And the second failure mode is even worse, security boundaries.
How so?
Well, the way a system remembers a cached prompt is by assigning it what's called a cache key.
Okay.
If that cache key is poorly implemented by a vendor or an engineer, say, it just looks at the text of the question but forgets to check the user ID, you get cross-tenant leakage.
Wait, really?
Yeah. You don't need a sophisticated hacker to breach your systems. You just need one sloppy line of code, and suddenly customer A types a generic question into your support bot and gets handed customer B's highly sensitive confidential account details.
That is a total nightmare.
It happens.
So if my data is stale and my security boundaries are bleeding, what is the third failure mode?
Retention. Because this caching and logging is happening entirely inside the provider's infrastructure, you lose all control over what is stored and for how long.
Right.
Picture an auditor or a regulator walking into your office. They want to know exactly why a customer was given disastrous financial advice by your automated system last week.
Okay.
You try to pull the logs, only to discover that the vital context the model relied on was cached outside of your control. It's already been overwritten, and you have zero proof of why the decision was made.
The audit trail just vaporizes.
Exactly.
So the structural integrity of the company's data platform begins collapsing under the weight of this invisible shadow estate, which means things are going to start breaking across the board.
And they are breaking right now. The first thing that collapses is observability. Model calls are scattered everywhere in developers' experimental notebooks, internal prototypes, shadow IT tools.
Just everywhere.
Yeah. When legal asks, where did this specific batch of customer data go? The engineering team just stares blankly. You can't govern what you can't see.
And if you can't see it, you fall into the second structural trap, which is governance by exception.
Oh, this is a classic trap. A developer builds a simple internal tool. They route a low-risk prompt, like maybe just summarizing a public news article, to a really cheap, fast model endpoint.
Right.
It works perfectly, so nobody monitors it. It gets rubber-stamped.
Sure.
But over the next 6 months, other teams bolt new features onto that tool. The prompt template grows. They add a retrieval step that pulls in internal memos.
Uh-oh.
Yeah, suddenly, highly sensitive proprietary documents are silently leaving the company perimeter and being sent to a third-party server, all running on a pipeline that was originally rubber-stamped as low risk.
And no one notices because the application itself hasn't crashed. It still technically works.
It works, but it's bleeding your IP.
Yeah.
And that leads to the final breakdown, which is corpus drift.
Right.
Everyone knows that retrieving specific company data to feed the AI is the real differentiator right now. So teams just start ingesting documents as fast as humanly possible. They dump entire SharePoint drives into the AI's memory.
Just a free-for-all.
Exactly. But nobody actually owns that data corpus. Nobody is in charge of pruning it, deleting old drafts, or verifying the accuracy. It just becomes this massive, stagnant swamp of text. And when you feed a swamp into an AI, you get a high-throughput misinformation machine.
Wow. So taking a step back, the core conflict here is really a massive clash of incentives. The economic incentive pushed by the vendors is to reuse context, rely on caches, and drop costs.
Right.
But the operational reality for the business is that reused context is frequently wrong or even dangerous.
Right.
Like stale documentation used to just be an annoyance. An employee might read an old handbook and have to be corrected by a manager. Now stale documentation is being actively executed upon by automated systems.
If we connect this to the bigger picture, it's exactly why we have to look at the specific AI models that are acting as the catalyst for this operational breakdown.
Absolutely. But we really need to pause right here, because we are about to discuss specific Chinese and Eastern models compared to Western ones.
Yes, very important point.
We want to be explicitly clear to you listening. This has absolutely nothing to do with geopolitics, national flags, or taking sides. We are strictly reporting on the source materials analysis.
Right. We aren't endorsing any nationalistic viewpoint.
Exactly. The source material analyzes this purely as an economic and operational shift. The value of these models and the disruption they cause isn't about where they were coded. It's entirely about the fact that they collapse the cost of good enough AI, completely altering the fundamental market dynamics.
Yeah, we are strictly looking at the structural impact on enterprise data systems.
Right, okay. Disclaimer over.
That context is vital, though, because when you look at a model like DeepSeek R1 and its various distilled smaller versions, its impact isn't political. Its impact is that it makes reasoning-based routing economically viable.
Meaning you can build a system that acts almost like a triage nurse.
Exactly. You can have a router that looks at an incoming task.
Yeah.
If it's a highly complex, multi-step logical problem, it pushes it to an R1 class reasoning model.
Okay.
But if it's just a basic formatting request, it instantly routes it to a cheaper, faster model. That sounds incredibly efficient. But from a governance perspective, you now have a dynamic system where data is bouncing between different providers in real time based on cost and complexity.
Which makes it nearly impossible to audit if you don't have the right infrastructure.
Spot on. Then you look at the Qwen 2.5 family of models. The analysis points out that this model actively encourages a fleet approach.
A fleet approach.
Yeah, it isn't just one massive model sitting in the cloud. It comes in multiple sizes, from heavy hitters to tiny versions that can literally run on a laptop. It has a very credible story for on-premise deployment.
Meaning you can run it entirely on your own private servers.
Yes, and because of that flexibility, it becomes the default workhorse inside internal corporate platforms. If a department needs a model but refuses to use the cloud for privacy reasons, they just spin up a local instance of Qwen.
Right.
And then you have the GLM family, where the ecosystem itself is the product.
So,
The derivatives, the fine-tuned versions built by random developers, they are proliferating so fast that traditional enterprise governance, which is used to approving one piece of software every 6 months, it simply cannot keep up.
and this creates a terrifying reality for the C-suite. You probably have executives sitting in boardrooms right now confidently saying, oh, our company has strict policies. We don't use any of these unregulated open models. We only use our approved enterprise vendor.
But they are absolutely using them.
Right. They're already inside the building.
The supply chain for AI is incredibly messy. An organization might encounter these models through a third-party endpoint they subscribe to for a completely different service.
Yep.
Or maybe a single developer brought in a fine-tuned derivative through a side door to solve a quick coding problem, and now it's baked into a critical workflow.
So how can a company possibly govern something that just sneaks in through the side door like that?
Well, the economics are moving so aggressively that these diverse model portfolios are arriving in your company by default, whether you designed it that way or not.
Which means hiding from this isn't an option. You can't put the genie back in the bottle, and you can't ignore the shadow data estates. We have to talk about how to actually fix it.
Yes.
And the good news is there is an engineering fix. We don't need magic. We need rigorous data plumbing. The source makes it clear. Your data platform has to become the new control plane.
It's a complete paradigm shift. You have to move away from treating AI like some magical black box and start treating it like traditional hardened software engineering. And the absolute first step is establishing a gateway.
Let's explain what that means practically, because right now, a lot of companies just use SDKs, right? Software development kits.
Right.
Basically, 50 different developers use 50 different toolkits to wire their apps directly to whatever AI model they want. It's a mess. The fix is replacing all of that with a central model gateway, like LitLM, Envoy, or Kong.
Exactly.
Think of it like a corporate firewall, specifically designed for AI prompts. Instead of a free-for-all, every single AI request in the entire company has to flow through this one central choke point.
Because the gateway is the only place you can actually enforce the rules. It's where you check data classification. If someone tries to send a confidential financial spreadsheet to an external model, the gateway catches it and blocks it.
That makes total sense.
It is where you mandate what gets logged, what gets redacted to protect privacy, and what gets routed where.
Here's where it gets really interesting, though. There's a quote from the analysis that I think perfectly captures the stakes here. It says, without a gateway, you do not have a platform. You have hope. Yeah. Why is hope such a terrible strategy in data engineering?
This raises an important question about how enterprises actually fail in the real world. A massive corporation doesn't fail because they accidentally picked the second best AI model on a benchmark test.
Right.
They fail because they lose the ability to operate their dependencies when the market shifts or a vendor changes its rules. If your entire security strategy relies on the hope that every single developer in your company is manually following data privacy laws while experimenting with AI, you are already breached. You just don't know it yet.
Wow. Okay, so step 1 is the gateway. Step 2 is observability in the data plane. Tools like OpenTelemetry, LangFuse, or Arise Phoenix.
Yes.
Because you can no longer just rely on a text log of what prompt was sent. You need to be able to reconstruct the entire transaction from start to finish. The goal is to have a stable request ID, a digital fingerprint, that follows the action across the entire workflow.
If a user asks a question, you need to be able to trace that specific digital fingerprint to the retrieval step. See exactly which internal documents were pulled, track it to the model call, and see the final output.
Yeah.
If you cannot join those dots, you cannot govern the system, and you certainly cannot pass an audit.
Which brings us to step 3, retrieval governance. We established that cheaper inference means companies are retrieving massive volumes of sensitive text to feed into model contexts. So if you're going to do that, you need strict ownership over the database. Whether you're using heavy infrastructure for massive scale like OpenSearch or Pinecone, or keeping it simple with pgvector or llama index, the rule remains the same. If no one explicitly owns the corpus of data, everyone uses it.
And if everyone uses it without an owner ensuring that the data is fresh, accurate, and properly permissioned, It will inevitably feed toxic or stale data into a critical process right at the worst possible moment.
Yeah. Step 4 is shifting how we test. Evaluation has become the new continuous integration. You look at tools like Ragas, PromptFoo, or DeepEvil. In traditional software, you wouldn't swap out your core database without running automated tests to ensure it doesn't crash the system.
Yet companies are routinely hot-swapping AI models in production just because a cheaper one became available that morning.
It's wild.
You have to build infrastructure that tests your prompts, your retrieval logic, and your routing decisions automatically before any new model goes live.
And the final piece of the platform fix is operational resilience. The architecture needs to maintain a highly capable fallback model. You want a frontier model from an entirely different ecosystem ready to go.
Yeah.
And again, not for political posturing, but for pure operational continuity.
Exactly. If a provider suddenly doubles their prices, or a geopolitical shift changes terms of service, or a massive outage hits one ecosystem, your business cannot grind to a halt. You need a switch you can flip to keep the lights on.
We have covered incredible ground today. We started with the realization that the plummeting cost of Eastern AI models completely shattered traditional Western billing structures, creating this vacuum where AI capability is basically free.
Yeah.
We explored how this cost compression causes usage to explode, secretly creating vast, unmonitored shadow data estates inside companies, the thousands of petty cache drawers of corporate data.
And we unpacked the very real systemic dangers of caching. How a simple cloud discount for reusing prompts can quickly mutate into a nightmare of stale information, bleeding security boundaries, and evaporated audit trails.
Right.
We saw how observability, governance, and data accuracy are the first pillars to collapse under this strain.
And most importantly, we mapped out the architectural fix, moving away from scattered integrations and towards strict centralized model gateways, implementing end-to-end observability, enforcing strict retrieval ownership, and treating AI evaluation with the exact same rigor as traditional software testing.
Excellent.
The ultimate takeaway for you listening: you have to start by building the control plane, not obsessing over the rate card. You have to treat caching as a massive systemic risk, not just a line item discount on your monthly bill.
The honeymoon phase of AI is over. It has officially moved out of the research lab and squarely into the realm of gritty, rigorous data engineering. If your platform cannot see and govern the mess simply becomes your new operating model.
Which leaves us with one final, deeply unsettling thought to mull over. Early on, the analysis briefly mentions AI coworkers, autonomous agents with names like Victor that live in your corporate Slack.
Right.
They don't just answer questions. They autonomously pull reports, build client dashboards, and execute workflows. So I want you to think about this. If unmanaged caching can silently ship yesterday's corporate policies as today's absolute truth, and we are rapidly handing over actual real-world operational execution to autonomous agent tools like Victor, what happens the first time an AI agent executes a massive, unrecoverable business action based entirely on a stale piece of cached context that no human being even knew existed?
I mean, that is the multi-million-dollar question, keeping every serious data platform team awake at night.
Thank you for joining us on this deep dive. Keep questioning the systems running silently around you, and we will see you next time.